This video is part of my free CCNA series, and it pairs perfectly with the earlier OSPF fundamentals, because once you understand neighbors and LSDB sync, the next two basics that show up everywhere are router ID and cost. Today we're covering two OSPF basics that show up constantly in CCNA questions and in real configurations: router ID and the OSPF cost metric. They're commonly searched together because the moment you start touching OSPF setup, you immediately run into both. How does the router pick its router ID? What does OSPF cost actually mean? And how does it pick the best path? So in this video, we'll do three things. Build a clean mental model of what a router ID is and why it matters. Learn the selection order, manual to loopback to interface. Understand cost as a path weight where lower is better, and how OSPF adds cost along the path. No deep formulas, no reference bandwidth tuning, no full labs, just the conceptual rules and the reasoning behind them. Alright, Section A, Router ID. What is it, and why does OSPF need it? A router ID is a 32-bit identifier that OSPF uses to uniquely name a router inside the OSPF process. It looks like an IP address because it's written in dotted decimal form. But here's the key. It doesn't have to be a real-life interface IP. It's an ID that's formatted like an IP address. So why does OSPF need a router ID? Because OSPF is building a topology map, the LSTB, and it needs a stable way to say that this router originated this link state information, or this router is my neighbor, this router is a DR candidate, or this router is the endpoint on this link. In other words, OSPF needs a stable, unique name for every router, and it uses the router ID for that. If router IDs change unexpectedly, OSPF behavior becomes unstable, and that's why router ID matters. Now, let's do the selection order in plain terms. OSPF chooses the router ID using a priority order. Manual router ID, then highest loopback IP, and then highest active interface IP. We'll walk each rule quickly. Rule 1. Manually set router ID. If you explicitly configure router ID for the OSPF process, that becomes the router ID. This is the most stable choice because you're not leaving it to chance. So conceptually, manual router ID equals higher priority. Rule 2. If not manual, OSPF chooses the highest IP address on the loopback interface. If there are multiple loopbacks, it chooses the highest IP address among them. Why loopback? Because a loopback is designed to be stable. A physical interface can go down. A loopback is a virtual and typically always up interface, so OSPF prefers something that won't disappear. So, highest loopback IP is second priority. Now, rule 3. If there is no loopback, it chooses the highest IP address on the active interface. That's the physical interface. If you have no manual ID and no loopback interface, OSPF falls back to the physical interfaces that are up, and again it chooses the highest IP address, so highest active interface IP is the third priority. That's a selection order you must know: manual router ID, highest loopback ID, and highest active interface IP. Next, uniqueness. Within the same OSPF routing domain, router IDs must be unique. If two routers end up with the same router ID, OSPF can't reliably tell which router is which, and you get the conflict. So router ID uniqueness is not a nice thing to have, it's mandatory. That's also why manual or loopback based router IDs are common. They reduce the chance of being accidental duplicates. Now, stability. This is why router ID matters so much in real networks. OSPF neighbors identify each other by router ID. If a router's router ID changes, other routers effectively see it as a different router. So router ID changes can trigger that neighbor resets, adjacency rebuilds, LSDB resynchronization, and that SPF reruns. In short, a router ID change can cause unnecessary reconvergence and instability. That's why engineers choose stable router IDs, often manually or via loopbacks. Now let's pivot. Router ID answers, who is this router? Cost answers, which path should I choose? So router ID is identity, cost is decision making. In OSPF, every interface has a cost value. Cost represents how expensive it is to send traffic out of that interface in the OSPF logic. OSPF uses cost to choose the best path, and the simplest rule is lower cost is better. Think of cost like a weight. A lower weight path is preferred. We're not doing formulas, just remember that cost is a metric, OSPF compares paths with it, and the lower cost wins. Here's the most important concept about OSPF path choice. OSPF does not look at only one link. It calculates the total cost from the source router to the destination. That total is cumulative. It's a sum of the outgoing interface costs along the path. So imagine two ways to reach the same destination. Path 1, A to B with the cost of 10. Then B to destination with the cost of 10 too. The total cost becomes 20. Path 2, A to C, cost 5. Then C to D, cost 5. Then D to destination, cost 5. The total is 15. Even though path 2 has more hops, it's still preferred because OSPF chooses the path with the lowest total cost. Now, OSPF is not fewest routers, it's the lowest metric. More hops can still win if the total cost is lower. So if you think hop count, that's bad. OSPF is cost-based. Conceptually, cost is meant to loosely reflect link speed or capacity. Faster links tend to have lower cost. Slower links tend to have higher cost. But for CCNA level understanding, the crucial thing is that OSPF treats cost as a number used for comparison. The lowest total cost wins. Now, the common mistakes that you need to avoid. 1. Router ID is always the highest interface IP. Not always. That's only the last resort after manual and loopbacks. 2. Router ID must match a real interface IP. Also not true. It just needs to be a valid 32-bit value formatted like an IP. 3. Router IDs can duplicate as long as IPs are different. Also not true, router IDs must be unique. 4. OSPF chooses fewest hops. No, OSPF chooses the lowest total cost. 5. Only the first link cost matters. No, OSPF adds all of the hops, all of the links across the whole path to our total cost. Now let's lock it in. Router ID is OSPF's unique name for a router. It matters because OSPF uses it for a neighbor relationship and building the LSDB. Router ID selection order is manual router ID if set, then highest loopback IP, and then after that highest active interface IP. Router IDs must be unique and stability matters because router ID changes can cause adjacency resets and reconvergence. Then for path choice, OSPF uses cost. Cost is a metric weight. Lower cost is better, and OSPF chooses the path with the lowest cumulative cost. It adds interface cost along the path. Now, if you have those ideas clear, you're ready to understand how OSPF chooses routes in real topologies.